Alright, welcome to my coronavirus classroom. This is your exam 1 review. It's ridiculous that we're here in a coronavirus classroom, so I'm wearing a ridiculous hat, showing you the truth of things, which is that every day I have these shoes on, although sometimes I do a picture, the expectation versus reality thing. So here we go, let's have some questions. The following cells are found in the pituitary: A, somatotropes, B, gonadotropes, C, neurons, D, all of the above, E, none of the above. The answer is all of the above. Now what if instead it said the following cells are found in the anterior pituitary? Well, this is a publisher question. I'm not putting my questions out on the interwebs for everyone to steal. So if it said anterior pituitary, the answer is not here, because for cells that are found in the anterior pituitary, it would be A and B only. Our somatotropes are in the anterior pituitary, and our gonadotropes are in the anterior pituitary. Our neurons are in the posterior pituitary. So if it said the following cells are found in the posterior pituitary, the answer is here, and that would just be C. But since we didn't specify which part of the pituitary we were talking about, the answer is all of the above. Okay, a deficiency in iodine will cause a problem with A, hypothalamic function, B, thyroid hormone production, thyrotrope function, or D, all of the above. So deficiency in iodine will cause a problem with hypothalamic functioning, thyroid hormone production, thyrotrope function, all of the above. Skip forward 10 seconds if you know the answer. If you don't, I'm going to finish the Jeopardy theme song. Alright, a deficiency in iodine is not going to mess with hypothalamic functioning. That's the hypothalamus. It has nothing to do with iodine. Not like directly. It will have an effect on thyroid hormone production. And that's because we have to have dietary iodine to add on to those tyrosines and thyroglobulin to make our T4 and T3. So this is the issue. C is the distractor answer. Our thyrotropes are going to function to do what they do, which is respond to TRH and release TSH. So TSH is going to go stimulate our follicular cells in the thyroid, but they're not going to be able to produce thyroid hormone because they don't have iodine. Alright? True or false? All glands must be under some type of hormonal stimulation. True or false? All glands must be under some type of hormonal stimulation. The answer is false. So some glands respond humorally, like the parathyroid glands are paying attention to the level of calcium in your blood. Some glands respond neurally, like the adrenal medulla, which is releasing norepinephrine and epinephrine, well, primarily epinephrine actually, in the blood in response to norepinephrine. Okay, when blood glucose drops, blank detects this and blank is released. So when blood glucose drops, beta cells detect this and insulin is released. Or when blood glucose drops, beta cells detect this and glucagon is released. Or when blood glucose drops, alpha cells detect this and insulin is released. Or when blood glucose drops, alpha cells detect this and glucagon is released. Alright, the answer is D. When blood glucose drops, alpha cells detect this and they're going to release glucagon. What does glucagon do? Goes to the liver and stimulates glycogenolysis, so we can break down our stored glycogen and release that as glucose to the blood until we come back to homeostasis by going to eating or something. Okay, the major targets of growth hormone are A, blood vessels, B, thyroid and adrenal gland. C, the liver and gallbladder. D, the liver, bones, and skeletal muscle. The targets of growth hormones are bones, skeletal muscle, liver. The primary target is the liver. The liver is going to respond and release insulin like growth factors that do all of this stuff. But alas, here we are, coronavirus classroom. That's the answer. Okay, so I wanted to quickly review a couple things with you just to show you what we're dealing with here. So this is, I'm using, to write your test, I'm using publisher questions. This is a publisher figure from the book. This is the slide that I took a picture of, your lab assistant took a picture of in my living room. This is a slide that you guys can look at on Mastering A&P. And I hear your words when you tell me, well I don't, I see your words, when you tell me that they look nothing alike. And I can kind of see that, but what they're giving you on Mastering A&P also looks nothing like what they're giving you in your book. And this is what you would be looking at in class. So we have to figure it all out. They relate. What are we looking at? Here's a seminiferous tubule. And here's basement membrane out here, and here's basement membrane out here. It's a connective tissue sheath on the outside of the testes. So just put that in your back pocket. Alright, so what's really weird, but I'm glad that we have this picture, is that like, what if I were to put a figure on there and ask you to label all these cells? Well, this right here, this big huge blob is the Sertoli cell, or a nerve cell, or a systemacyte. They're huge, and they're supporting these developing spermatocytes as they're going through meiosis. So what's A? Well, that's a spermatogonium. What's B? It's a daughter cell. What's this? This is a spermatocyte. These are different spermatocytes at various levels of development. You don't have to worry about that, but you do need to know the cell types that we find. So, and then here down here we have the spermatids. So this is what I took in my living room. This is what you have on Mastering A&P. So I'm going to use one of these two types of figures probably for your practical exam, definitely for your practical exam. You might see something like this on the lecture portion, maybe not, but you'll definitely see something like this. So what could I ask you? Well, this is pointing right here. I could say, what structure is this? What cell types are present? To what does it respond and what does it do? Well, this is a seminiferous tubule. The cell types present are Sertoli cells, spermatogonium, spermatocytes at various stages of development, and spermatids. To what does it respond? Hormonal stimulation due to FSH. And what does it do? Produce, I don't know, spermatids. Our Sertoli cells are going to respond to FSH and produce inhibin. They're going to respond to FSH and produce androgen-binding protein. They're going to respond to FSH and nurture the developing spermatocytes. So that's all that I can see right there. And look, I can see that right here. Okay, so now what this book, I window snipped this from Mastering A&P. What this is pointing out is what type of cell? An interstitial endocrine cell, or our Leydig cells. So we can see those here, in between all of our seminiferous tubule. Here they are, and here they are, and here they are, and here they are, and here they are. They're just in between our seminiferous tubules. So I can say to you, to what do they respond? What receptor type do they have? They respond to LH. They have LH receptors. What do? They increase testosterone production. So those are the things we can get from there. Alright, let's have some questions. Do you see, this is why Alex is here. He's here to block this reflection every day. So you guys think he's being ridiculous, but he's actually functional. So the darkus and premaster muscles are important to the integrity of the male reproductive system. Which of the following best describes the role they play? A, they contract to push sperm along the ductus deferens. B, they regulate the temperature of the testes. C, they are responsible for penile erection. D, they contract to allow ejaculation. I don't know, maybe here instead of doing the Jeopardy, I could do and the answer is B, they regulate the temperature of the testes. So remember, the cremaster functions in both hot and cold. It can relax in hot temperatures to suspend the testes a little bit further away. When it's cold, it can contract and pull the testes up toward the body. And then the darkus is going to contract and pull the testes in the body. All right? Which of the following hormones controls the release of the anterior pituitary gonadotropins? A, LH, B, FSH, C, GnRH, D, testosterone. Okay, so which hormone controls the release of anterior pituitary gonadotropins? The gonadotropins are LH and FSH, and the gonadotropin releasing hormone is going to be the hormone that stimulates their production and release. The structures that receive the ovulated oocyte, providing a site for fertilization, are called the A, Graafian follicles, B, uterine tubes, C, infundibula, D, fimbriae. Jeopardy style. I'm glad we had this discussion actually, because I only really talked about it briefly in lecture, that where we actually have to have fertilization occur is the uterine tubes. So in order for there to be enough cell divisions to produce the hormones necessary to burrow into the uterus, we really have to fertilize in the upper third of the oviduct, maybe upper 2/3 of the oviduct. Okay. Both female reproductive cycles are under the direct influence of estrogens. True or false? You might be sitting there, what the heck are you talking about, both female reproductive cycles? I'm talking about the uterine and the ovarian cycle. Are both cycles under the direct influence of estrogens? And the answer is no. The ovarian cycle is not under the direct influence of estrogens. The ovarian cycle is under the control of our gonadotropic hormones. The ovaries are under the control of FSH and LH. And those changes in FSH and LH are going to cause the changes in the ovary that cause the changes in estrogen production. Estrogens are what's controlling the menstrual cycle. Okay, so that actually brings me to a good point. I want to kind of just think about the 4 figures you can look at in your book to kind of bring it all together. And if you can understand what's happening in the female reproductive cycle with all of these 4 figures, then that's like most of what you need to understand for female reproduction. So if we think about it, then what we see in our book when we look at if we're looking at our 28-day cycle, here's day 28. Really what we're trying to get to is day 14 here, where we can ovulate and hopefully fertilize this oocyte. Come on, Alex, block the spot. Then what we're doing here, as far as all of our figures go, remember in our follicular phase, if we're thinking about our ovary, we've got our follicular phase, we've got ovulation, and then we have our luteal phase. And what's happening in our follicular phase is our follicles getting bigger and bigger and bigger till we get this follicle that's going to rupture. So what this is doing is causing increasing estrogen hormone levels. And then after ovulation, our progesterone is going to go up. So in your book, you've got all these different figures. And you've got one that shows FSH and LH. So that's what I kind of want to talk about. I want to talk first, let's think about all those figures. What's controlling our ovarian cycle is the hypothalamus. And that's because it's releasing GnRH, which is stimulating our gonadotropic cells. So our gonadotropes are going to release our gonadotropic hormones. And at the beginning of this cycle, FSH is kind of high. It's the follicle stimulating hormone. And what we're doing is stimulating follicle development. So FSH, we'll have here in orange, is going to start kind of high, but then it's going to drop off as that follicle is developing, because a bigger follicle is going to have more granulosa cells. It's going to produce more inhibin, which is going to inhibit FSH. So it'll kind of drop off. When we have that LH surge, there will be a little bit of an FSH surge. And that's because if you have a surge in GnRH, you're going to have a surge in both of our gonadotropic hormones. But then FSH is going to drop off and stay low. The other hormone picture that you can see there is what's going on with LH. So LH starts a little bit lower than FSH, but then it's going to start going up. Because increasing GnRH levels are going to increase the stimulation of our gonadotropes, but our FSH is going down due to inhibin. Our LH is going to go up because our follicle is starting to release more estrogen. So that increasing amount of estrogen is increasing GnRH, which is going to increase our gonadotropic hormone release, but specifically LH, because we're inhibiting FSH. So what happens is LH is going to go up, then at day 14 we're going to have an LH surge. There is a little bit of a surge in FSH as well, but what's really important is that LH surge, then we're going to decline, and we're going to drop off. So these changes in gonadotropic hormones cause these changes in the follicle, or in the ovary, I guess I should say. So we ovulate, and then we get our corpus luteum, and then we get our corpus albicans. So these changes in their gonadotropic hormone level cause these changes in the ovary. These changes in the ovary cause these changes in hormone production. So as my follicle is getting bigger, I'm going to release more and more estrogen. And then at ovulation I have a little bit of a dip, but it's still going to stay kind of high. So this is my estrogen. Progesterone is low until ovulation, and then it's going to go high. Okay, so these changes in the ovary cause these changes in sex hormone levels, where estrogen increases, then dips a little bit, then it's going to stay high. Progesterone is low throughout the follicular phase, then goes up during the luteal phase. These changes in sex hormone level are going to cause the changes that we see in the uterus, because the uterus is the target for our sex hormones. So as estrogen is increasing, this is our stratum basale that's going to stay the same thickness, but as estrogen is increasing, some of those cells are going to start dividing by mitosis to give rise to our new functional layer, and then as estrogen is increasing more, that's going to happen more. So all throughout our proliferative phase, we're increasing cell number in that stratum functionalis, and then when progesterone comes on board during our secretory phase, now we're increasing the thickening even more. Estrogen is still helping to stimulate that hypertrophy and hyperemia. Estrogen is still helping to stimulate our increase in cell number through mitosis, but now progesterone is on board and stimulating hypertrophy and hyperemia, so that the thickness of our uterine wall is even better, and we get more uterine glands, and we get more blood vessels, so that we have a nice nutrient-rich environment for hopefully that fertilized oocyte to go off and burrow into. So this is the uterus and the thickening of the functional layer in response to my sex hormones. These are my sex hormones that are released in response to these ovarian changes. And these ovarian changes occur in response to these changes in my gonadotropic hormones. So have a look at that picture in your book and make sure you understand it. Because if you could understand all of that, then that goes the female reproductive cycle. So that really kind of brings it all together. So have a look at that. And then the last thing I kind of want to talk to you about is, again, a little comparison of these slides that the lab assistant gave you to what we have, like, in your book, or what Mastering AMP is giving me. So this was a figure that I pulled right off of Mastering AMP, or Practice Anatomy Labs, and it's giving me a sagittal section of the ovary. Well, what can I see here? What the hell can I see here? I can see this is an oocyte, there's an oocyte, this little guy there's an oocyte, that's an oocyte. Here's a primordial follicle. I can tell that? Yes, I can. That's an oocyte. So here's a primordial follicle. One oocyte with one little tiny layer of cells around it. Okay, so other things that I can see here. This is a secondary follicle, a late secondary follicle, because we've got two antrum. Here's a secondary follicle. See, there's like two little antral spaces here filling with antral fluid. That's going to get bigger and bigger and become this tertiary follicle. So we can see here's a secondary follicle over here. This is a secondary follicle. This is a secondary follicle. And so in a secondary follicle, that antrum is just getting bigger as we're filling with fluid. That antrum is going to get bigger, and that antral fluid is going to push the oocyte to the side. And then this oocyte is going to be the one that ruptures off. So I know that it seems crazy, but you can see a lot here. And actually right here, this is a primary follicle. So I can see all these tiny little primordial follicles out here and primary follicles here. So what are we looking at here? So see this tiny little, there's just one cell around there. One layer of cells around there. That's a primordial follicle. Where's my primary follicle I just saw? It's right here. So see down in here where I've got this oocyte and just one layer of cells around it, that's primary. Whereas like up here I'm secondary, and I've got my oocyte, my developing antral spaces filling with antral fluid. So like if you were to look at this slide on a practical, what could I ask you? Well, what cell type is present? Right there I'm pointing in the oocyte. What about what's right here? Those are thecal cells. What about right here? Granulosa cells, okay? So to what does this respond? LH. To what does this respond? FSH. So know the form, know the function, and that's how it relates. Happy studying. See you soon.